Welcome to Session 4, Fractional Exponents, Negative Exponents, and Radicals. This lesson develops mathematical reasoning that stays reliable when a problem looks unfamiliar. You will learn to translate roots and rational exponents, to apply reciprocal rules correctly, and to simplify radicals exactly. These are connected habits, not isolated tricks. Keep a pencil ready. We will build a mental model, use a repeatable method, solve a demanding example, diagnose an error, and finish with an independent checkpoint. Start with this principle. Exponent laws describe operations on the same base. Use this visual structure. A to the power m/n equals nth root of a to the power ma to the power k equals 1/a to the power k. Read every symbol and label before calculating. The first goal is to translate roots and rational exponents. Connect it to the second goal. Apply reciprocal rules correctly. Correct calculation begins with correct interpretation. When the surface details change, search for the same relationship underneath. Transfer means choosing the structure from evidence rather than waiting for a familiar-looking example. Step 1. Identify the base and exponent structure. State the target and preserve its units or conditions. Step 2. Use denominator as root and numerator as power. Use a separate line so signs, factors, and labels remain visible. Step 3. Move negative powers across the fraction bar. Keep the reasoning efficient, but never skip an operation that could hide an error. Step 4. Estimate the exact result. Verification is part of the solution because it tests the answer from another direction. Signal 1 is exponent m/n. Respond by remembering. Take the nth root and mth power. Name the response before calculating. Signal 2 is negative exponent. In that case, use a reciprocal. The form tells you which tool fits. Signal 3 is radical denominator. Remember, multiply by a radical form of 1. This separates plausible work from valid reasoning. If you cannot name the signal, pause and classify. A deliberate choice of method is usually faster than repairing a rushed setup. Here is the challenge. Simplify p to the power 2p to the power minus 5 p0. Restate what is requested before touching the choices. The first move is identify the base and exponent structure. Apply it directly to the quantities and conditions in this problem. Now use the core reasoning. Subtract exponents. Minus 2 minus 5 equals 3. Keep each equality, comparison, or unit conversion visible. Pause for a midpoint audit. Check copied values, signs, units, restrictions, and whether the current result is the requested quantity or only an intermediate value. Continue by applying this control. Move negative powers across the fraction bar. The explanation supports one option without relying on its position. The mathematical conclusion is p cubed. State it with any required units, interval notation, or restrictions. The final answer is p cubed. Compare it with the exact target and reject any choice that represents a common intermediate step. Verify from another direction. Convert the result to a rough decimal and compare scale. The check should use evidence independent of the original calculation whenever possible. Try this checkpoint without copying the example. Evaluate less than or equal to 8 to the power 1/3 to the power minus 2. Decide which mathematical fact controls the answer. Pause and write one line of reasoning before committing. A visible decision is easier to inspect, explain, and correct than an unsupported guess. F-focused hint. 8 to the power 1/3 equals 2, and 2 to the power minus 2 equals 1/4. Use the hint to repair the setup, then finish the reasoning yourself. The accepted answer is 14. Explain why it works, and name the earliest line that would reveal a likely error. Central message is to translate roots and rational exponents. Combine that with the discipline to apply reciprocal rules correctly. Finish by remembering to simplify radicals exactly. A result becomes dependable only when the method and verification are both clear. Reflection. Did you change the sign of a value or correctly change its reciprocal position? Name the exact point where an incorrect path would first become visible. Practice one fresh problem for 8 to 12 focused minutes. Keep the work readable, verify independently, and carry the routine into the next session. Before moving on, close the notes and explain the method aloud from memory. Then invent one small variation, predict how the answer should change, and verify that prediction with a complete calculation.